Look around the room for a second. Just look at a table, a solid, boring, totally ordinary table. Have you ever actually stopped to wonder what it's made of? Welcome to this explainer, by the way, where we're going to dive into exactly that. If you take an axe and chop that table in half, well, it's wood. Zoom in closer and it's molecules. Zoom in again, atoms. If you look inside those atoms, you find protons and neutrons. And if you look inside those, you get quarks. And that's it. That is exactly where our map of the universe ends. Our current understanding of physics hits an absolute brick wall right there. We look at a quark, and we have absolutely no idea what it's made of, or if it's even made of anything at all. String theory is what some physicists think might be waiting on the other side of that edge. Now here's something that should genuinely bother you. Right now, we have two theories that describe the universe, and they are both spectacularly good at what they do. General relativity describes the big stuff: galaxies, gravity, the heavy, bending shape of space itself. Quantum mechanics describes the small stuff: atoms, particles, the completely unpredictable behavior of matter at the tiniest possible scales. Both are completely tested, both are confirmed. Both are among the greatest intellectual achievements in human history. And they completely contradict each other. Because they can't both be right. Not fully. When you try to apply them to the exact same situation, say the inside of a black hole where gravity is incredibly extreme and quantum effects really matter, the equations literally break down. They just produce nonsense. You get infinities popping up where there should just be normal numbers. Think about that. The universe, at its most extreme limits, literally cannot currently be described by our best physics. That broken math, that massive chasm between the big and the small, that's the exact gap string theory is desperately trying to close. String theory proposes that every particle in the universe is not a tiny dot, it's a microscopic vibrating loop of energy. Think of a guitar string. A guitar string vibrating slowly produces a low, heavy note. Pluck it so it vibrates incredibly fast, and you get a high note. The string itself doesn't change, right? Only its vibration does. Well, string theory says matter works exactly the same way. An electron is not fundamentally different from a quark. They are the exact same kind of string, just vibrating to a different tune. Just let that sink in for a second. Every particle in existence, every building block of matter, every single force carrier that creates gravity or light, it is all just one type of object, doing different things. One thing, vibrating in different ways. That's it. That's all matter is. Maybe. Wait, actually back up for a second. This doesn't just sound poetic, it actually fixes the math. Physicists recently used a mathematical trick called the bootstrap method. Basically, they started with just a few basic, undeniable rules about how particles crash into each other at extreme high energies. They didn't even assume strings existed. But to stop the math from hitting those broken, non-physical infinities we talked about earlier, the particles had to soften. They had to smear out. The math automatically demanded an infinite tower of vibrating harmonics. The strings just naturally fell out of the equations. If strings really are the base layer of reality, and they naturally fix the math that completely breaks when quantum mechanics and gravity collide, then this might actually be the bridge, the theory of everything physicists have been hunting for over 100 years. But to make it work, there's a wild catch, and it is a big one. For the math of string theory, specifically something called M theory, to actually work, the universe requires 11 dimensions. And yes, that sounds completely insane, say with me. We experience length, width, height, and time. That's 4. So where exactly are the other 7? Think of a garden hose. From far away, it looks like a one-dimensional line, just a streak of green across the yard. But walk right up to it, and you see it actually has a curled 3D surface. It has width and curves that you just couldn't perceive from a distance. String theory says the extra dimensions are exactly like that. They are curled up so microscopically small that we simply cannot see them, but they are there. And their shape determines everything. The specific, hidden shape of these curled dimensions dictates exactly how the strings are allowed to vibrate, which means their shape physically determines what particles exist, what matter is, what we are. The shape of dimensions too small to even see might dictate the entire rulebook of the universe we live in. But if that's true, why haven't we found them? Here is the brutal honesty. These strings are unimaginably small. That's a billion times smaller than a single proton. That means no particle accelerator ever built or literally ever likely to be built by human hands could detect them directly. They are entirely beyond our physical reach. Because of that, there is a very real, very intense argument happening right now in physics. Some credentialed, completely serious physicists look at the math and say, this is it, this is the ultimate theory of everything. Others look at it and say it's not even wrong. Because a theory that cannot be tested simply cannot be proven wrong. And a theory that cannot be proven wrong tells us nothing real. This is where it gets genuinely weird. When theorists really push the math, they found what they call the landscape problem. The equations allow for up to 10 to the power of 500 different possible ways to curl up those extra dimensions. That is a 1 with 500 zeros after it. It's a completely incomprehensible number of possible universes, all with completely different laws of physics. If the theory can predict almost any universe, does it actually explain our universe? That argument is still happening right now. In universities, in journals, in late-night arguments between physicists who genuinely disagree. We honestly do not know yet if this is the deepest truth of the cosmos or just the biggest mathematical mistake in the history of science. But here's what I keep coming back to. Look at us. Look at this beautifully human obsession. We look at a star or a table or a grain of sand, and we absolutely refuse to stop digging until we hit the absolute bottom. String theory might be right, it might not be. But the search for a single equation that explains everything, one rule that unifies all of matter, all of energy, all of space and time, that search is one of the most purely human things we have ever done. We didn't need to know any of this to survive. We just couldn't stop asking. And honestly, I think that's the most beautiful thing about us. Thanks for joining this explainer. Keep asking questions. See you next time.